My name is Dr Michelle Dickinson. I've learned that breaking things down is the easiest way to understand them. So join me. We'll break down scientific concepts, meet some amazing scientists and inventors, and help you discover the world around you.
Hi, I'm Dr Michelle Dickinson, and today we're going to be talking about plastics. Plastics are everywhere, from cars to clothes, bottles to boats. It's almost impossible to go through a day without actually touching plastic. But what exactly are plastics? Are they all bad for the environment? Or can we make good plastics too? By the end of this episode, you'll understand where the ingredients for plastics come from and how they're made. We'll look at different properties of plastics and all of their different uses, which are almost endless. We're also going to do a couple of experiments that will show you what the secret numbers mean on the bottom of plastic bottles, as well as learning how to make a sustainable plastic replacement that you are going to be able to eat. To join in today, you'll only need a piece of fruit, ideally a banana, a nut, I have an almond, and a couple of items of plastic from around the house. And of course, don't forget your notebook and pen so you can write down your observations. If you haven't got those to hand, go and grab them now. A bit later in the show, I'll be checking in with one of my science helpers who'll be joining us from home and speaking to one of my friends who'll be able to tell us even more amazing things about their research into plastics. Let's get started. Okay, so plastics are in so many things, and it's pretty hard to imagine our lives without them. Even our money is made from plastic. But let's break this down and look a little bit closer. Scientists don't actually call plastics plastic. Their real name is polymers. Poly means many, and mer means group. So plastics are just made up of many groups of the same chemical. So where does plastic come from? Traditionally, plastic is made using oil from underground, and oil is a non-renewable resource. If we keep taking oil from the ground, eventually it will run out, which is one of the reasons why people think plastic is bad for the environment. Once you have your crude oil, you then heat it up and you separate it into its different chemical groups. To make plastic, we want to pull out a specific monomer and multiply it. There are lots of different monomers to choose from, and they each make different types of plastic. The monomer you choose becomes the base of our plastic. For example, ethylene is the monomer or mer in the plastic polyethylene. To turn it from a monomer to a polymer, you need something special called a catalyst, which will help to break down some of the bonds so that the ethylene groups can all join together and form a chain. This is called polymerization. After polymerization, you now have your polymer, or plastic. Normally, this base plastic is made into tiny beads called nurdles, which are then shipped all around the world to be molded into whatever shape you like this container. If we look at a polymer up close, it would look like a pearl necklace, where every pearl is, in our example, ethylene. But in other examples would be different, like a necklace made up of styrene for polystyrene, which you may have seen in packaging materials. Plastics can also have really different properties, which means they look and feel really different to each other. Some are hard, some are soft. Some are strong, some are flexible. You get the picture. I like to think of polymers like a plate of noodles, where every strand of noodle represents a polymer strand. So they can either all be tangled up like this together, or they can be lined up nicely in a row. We call these two orientations amorphous or crystalline, and that's what determines how the plastic behaves. Amorphous polymers usually have lots and lots of gaps where light can pass through, which means that they are transparent or see-through. like this. It also makes them more flexible and bendy as they can slide past each other before breaking. Crystalline polymers tend to be opaque, which means you can't see through them because their structure is very closely packed. They tend to be less flexible and more likely to break instead of bend when a force is applied to them. Right, now we understand a bit about what plastics are. We need to talk about the big thing we need to do with our plastic, which is to recycle or reuse it wherever we can. Part of the problem here is that not all plastics can be recycled. The type of plastics that can be recycled are called thermoplastics. Thermo means heat, and these plastics soften as they get hot, meaning that we can get them to flow and then mold them into new shapes to make new things. This is recycling. Plastics that you can't recycle are called thermosets. These can't soften when they're heated, which is not always a bad thing. For example, you wouldn't want your electrical socket to melt onto the wall when it got hot. So if we were to group plastics, then we have a group that lasts a long time, like an electrical plug, plastics we can recycle and make new objects from, and then we have plastic that we're all working hard to cut down on, single-use plastic. This plastic, which is especially common for packaging things, can only be used once. At best, it will sit in a landfill, but sometimes they can make their way into our natural habitats, like the ocean. I'm sure you've heard about cutting out single-use plastics before, especially in places like our supermarkets. Anyway, back to our recycling. I've got a couple of experiments to help us think about plastics and how we use them. Let's give my science helper a call to give us a hand. Hi Rakei, how are you?
I'm good.
So we're going to do some science today. Have you got everything that you need for this? Have you found some plastic in your recycling bin?
Yes, it's right in front of me.
Awesome. Okay, Rakei, can you explain to me what plastics you have found in your house?
I found a lunchbox, a juice box, and another juice box.
Okay, and do you think they're made out of the same thing or different things?
They're all different types. Obviously, this is clear, this is not clear, and this is a lunchbox.
Very good. So what you just did then is talk to me about the properties of plastic, which is exactly what we're going to do today. We're going to go in a bit of a treasure hunt though. So now that you've found your plastics, here's what I want you to do. Pick up one of your plastic items and turn it upside down and see if you can find for me a number inside a triangle shape of arrows.
Yes, I can.
What number do you have?
A 5.
So 5 stands for the type of plastic that's called polypropylene. And polypropylene is a special type of plastic that is really, really tough and very strong. Do you think lunchboxes need to be tough?
Yeah, they do because they can fall out.
Exactly, and I definitely sit on my bag sometimes when my lunch is in there. So my lunchbox is made out of a 5 polypropylene because it's incredibly strong. It means that even if I sat on my bag, my sandwiches would not be squashed. So let's look for a different plastic. Pick up one of your other items and let's see if there's a different number. It might be on the bottom. Take a look on the bottom.
Oh yes, I do see it now.
What number is that?
It's a 1.
So number 1 stands for polyethylene terephthalate, which is a different type of plastic. Now this plastic is usually see-through. Can you see through it?
Yes, I can actually. Some parts I can't, but mainly at the top.
So why do you think it would be useful for a plastic to be see-through?
Because then after you can see if it's, full, down, empty.
Very good. And so this is a plastic that is also tough, which means that we can stack lots of them together in a truck. And that is a great plastic. That's a number 1. Let's go to your final bottle. Can you see if there's a number on that one for me?
It's number 2.
Number 2. And you'll find number 2s on things like milk bottles, and that stands for high density polyethylene, or HDPE. And there are 2 types of polyethylene. The high density one is also very tough. It's great for bottles like this that are going to be carrying lots and lots of liquid. You can also get a number 4, which is a low density polyethylene. It's the same chemical, but there's a bit less of it. And we use those for sandwich bags or plastic carrier bags. And so they're also made out of the same types of material. What it means is the next time you pick up something plastic, you can actually look at the number underneath and figure out what type of plastic it's made from. Is that cool?
Yeah, that's actually quite interesting.
Now, the next experiment that we're going to do is going to look at a different type of plastic. So what I have in front of me here is a birthday candle. Have you ever had a birthday candle on a cake before?
Yes, I have.
And the birthday candle is made out of a certain type of material. Do you know what candles are made from?
They're made from wax?
Do you think we make candles from earwax?
No, I don't really think we would. That would
No,
kind
because
of
that's
be gross.
disgusting, right?
Yes, that would be disgusting.
So we actually make this type of wax from a plastic.
Oh.
So in the same way that your bottles and your lunchbox is made from plastic, which is a petroleum-based material, so is your candle. Now, the challenge with these plastics is they're made from something called crude oil, which is a non-renewable source, meaning that if we keep digging it up out of the ground, eventually we may run out. And so I'm going to show you an experiment where you can make a type of candle that doesn't use crude oil and you can eat the candle at the end. So what you need to do is grab a banana and a nut.
Okay.
Those look great. So what I'd like you to do is cut the banana, keep the skin on for now, so you can cut it into a shape that looks like this. Ideally, you want your banana shape to be able to stand upright.
Okay. Done.
So now you're ready to peel your banana and then stand it upright on your chopping board, like this.
Done.
Next, you want to take your nut. Now, I have a slither of nut here. This is an almond. Make sure you peel the skin off and you just have a small bit of nut, not the whole nut there. And then we're going to put the nut into the top of our banana so it looks like a candle.
Okay.
Fabulous. I'm going to add my secret ingredient, which you don't have there, but this is my favorite thing to do. I'm going to put a few chocolate chips on the side of my banana because I like chocolate chips and banana. What we know is that petroleum is an oil, and that's the bit that burns in our candle. Now, do you think that bananas burn?
It's moist, so not really.
That's true, so bananas are not going to burn, so that's not the part of our candle that's going to create the flame. Did you know that nuts also are filled with oil? So just like our candle, nuts may burn, so this is going to be our test. Do you have an adult close by to supervise you?
Yes, I do. My dad.
Okay, perfect. So get your dad to keep an eye on you. Here's what we're going to do. I'm going to see if you can light your nut and get it to actually create a flame just like a candle. Okay, let's see what happens.
Yep, I got it.
Okay, I'm going to set mine alight too. What usually do you do when it's your birthday with a candle?
I would blow it out.
Okay, we're going to blow ours out together. 3, 2, 1, blow. Now, what you probably wouldn't do on your birthday is then eat your candle, but luckily this is the type of candle that you can eat. So when your nut has cooled down enough, you want to take the nut bit out because that's actually going to be black and taste like charcoal. That is no fun. And you're going to be left with a delicious banana.
Wow, that's actually quite amazing.
That's
How
good.
You can eat your own candle.
There you go. Plastic science that you can eat. Was that fun?
Yeah, it was.
Hey, Rakei, thank you so much for helping me today. I'll see you later.
See ya.
Okay, after any experiment, we need to write down our observations. These help us to understand our results and make interesting predictions for our next experiments. So, observations. What did we see? We saw that we can tell the type of plastic something is made from by looking for its recycle number. We also saw that different plastics have different properties. And we saw that when we lit the nut, it burnt using the natural oil that's in the nut. And this comes from a renewable source. Now we can look at our observations and reflect on them. By asking questions about why something happened or how we might make it happen again, we're really starting to understand the science behind it. For example, I know that plastics are made from oil and that a nut has oil in it. The oil is why the nut can burn. What are some other natural resources that also have a high oil ratio? These are all great questions on your learning journey. Plastics aren't inherently bad, but we need to find more sustainable ways to make them and use them. There are lots of scientists around the world trying to do this every day. But what do sustainable plastics mean? We're going to talk to someone to find out. Dr Florian Greichen is a chemist working on creating brand new ways to make plastic. He's passionate about inventing sustainable materials created from renewable sources. Florian's goal is a world that mimics nature, where nothing is wasted and everything is recycled. Hi Florian, how are you?
Not too bad, how are you?
I am good. Can you just introduce yourself, please?
My name is Florian Greichen. I'm a scientist working for Scion in Rotorua.
And so, did you like science when you were a child?
I was always into mixing of things, like mixing and making of portions, for example. But what I personally always wanted to be is an astronaut. And I still would like to be one, and I hope to be one day.
Well, it's never too late. So, Florian, if I were to ask you to describe what you do in one sentence, what would you say?
To make sure that everything that can be made from fossil fuels today can be made from a tree tomorrow. The job for the scientists in the future is to look at plastic in a different way.
And what is the coolest thing about your job?
That we can take a tree, we take it apart, we apply heat, pressure, enzymes, catalysts, water, or other things, and turn the tree into its fundamental building blocks. And we are looking at what people might refer to as waste and use it in materials and use it in products. So this spoon knife that we are making out of bioplastic, but we're also using kiwi fruit skin, kiwi fruit pieces, skin pieces, so you can see the darker points here.
So you're using bits that we normally would throw away as well to make new products?
Absolutely. So we're looking at nature. Nature is an amazing artist. Nature is an amazing designer. Yeah, we're trying to learn from nature and using everything we can.
So we've talked a little bit today about sustainability around plastics. And a lot of people think sustainability just means recycling the plastic that we currently have. But your work is based around an overall sustainability, which is to take things that maybe we hadn't even considered before to make different types of plastics. Is that right?
That's right, yes. So we're looking at plastics in a completely different way. So we are looking actually at the most fundamental part of plastic, which is the carbon. And we're trying to think about all the ways we can reuse this carbon, be it through materials coming from a plant or through recycling or through CO2 in itself. So everything that avoids digging into the ground, taking fossil fuel out of the ground, basically using more of a resource that is not infinite.
And before we go, is there one plastic fact that you wish the world would know, and will you share it with us?
If you look at the next generation of planes, the Dreamliner, the A350, 50 to 80% of these planes are made from plastic or plastic composites and making it much lighter and fuel efficient. The amount of food we are saving by using plastic appropriately. I wish people understand that plastic is not the problem, it's what we do with it.
Florian, that has been fascinating, thank you, and really helped us on our journey of not only understanding plastics, but what it means when we talk about sustainability. Thank you for your time today.
No problem, thank you.
Okay, so we've talked a lot about plastics and what they are used for. But there's actually a whole other area that we haven't explored yet, and these are called microplastics. Microplastics are tiny pieces of plastic that we find literally everywhere. They're usually made up from larger pieces of plastics that have been left out in the environment where instead of being recycled into something else, they're breaking down into smaller pieces. Just one of the facts about plastic is that other chemicals like to stick to it. So there's something about its surface that makes it easy for other toxins and chemicals that it touches to attach themselves to it forever. Microplastics have a high surface area to volume ratio because they're so teeny, which means there's lots of area for these chemicals to stick to. Now, this is a problem if you ingest them because you're basically just eating chemicals, and we're not sure how those have an effect on our body. At the moment, we're still learning about the long-term health effects of microplastics. But what we do know is that when these microplastics get out into our oceans, fish and other sea creatures are eating them. This can cause two sets of problems. The first is that these sea creatures might feel full from eating all the microplastics. But of course, it isn't real food, so they can become unwell from poor nutrition. Also, these microplastics can get stuck into their digestive system, which is also bad news. The second challenge is that humans, like us, eat seafood. And this means that we, in turn, are also eating these microplastics. And we're not sure, but we think they may cause issues to our health as well. Now, humans are amazing. We're constantly learning to experiment, improve, and innovate. But when you create something new, like plastics, which we only invented 100 years ago, there can be unintended consequences. Plastics are a really complicated topic, both scientifically speaking and because of the environmental impacts that they contribute to as well. We rely on plastics so much for some pretty important things, like keeping our food fresh, keeping medical equipment sealed and sterilized, or making hard-wearing but flexible tires for our cars. However, we also need to think about our planet and how we might be able to modify plastics in a way that keeps their function while also reducing their environmental impact. This is the big focus that is keeping scientists busy, and I'm pretty sure that you have some ideas that can help too. There's so much more to discover. Just keep asking questions and testing your theories by experimenting. Teachers and parents, don't forget to visit nanogirlslab.com, where we have downloadable content to help you continue on your science journey with plastics. Thanks for watching. How much plastic has been made since it was invented? How many plastic bottles do you think are bought every minute? What would happen if we stopped making plastics tomorrow? Do you think we could